Hi everyone. Today we'll be talking about net ionic equations, and the idea behind that is to determine what ions had to come together in order to make a precipitate, which, as we should know, is an insoluble solid that forms when two ions come together that don't normally dissolve in water. So the whole process that we're going to go through today is to figure out what made the precipitate, what came together and caused something to not dissolve in water because it is insoluble. So the steps are to write and balance the chemical equation, determine which ions will be aqueous in solution and which will form a precipitate using our solubility charts. We have to write the states of matter and give their ions their charges. Then we will separate everything into its individual charges except for the precipitate. And then from there, we will determine what our spectator ions are. So the spectator ions are the ions that appear on both sides of the equation. They're on the reactant side and the product side. And because they appear on both sides unchanged, we know that they didn't really partake in the making of the precipitate. So before we continue, we have to be able to read this solubility table that appears on the back of your periodic table. Basically, everything in this quadrant here in the top left is always soluble in water. Okay, so acetate, ammonium, nitrate, cyanide, all of these are always soluble in water, and there are no exceptions. Okay. However, down here, bromine ion is soluble except when it's with silver, lead, and mercury. Sulfate, for example, is usually soluble except when it's with strontium, barium, lead, or mercury. So these are the exceptions to make it. In this case, they would become insoluble if they are part of this exception. On the bottom here, we see the ions that are normally insoluble, and those also come with exceptions. So carbonate is normally insoluble, except when it's bound to ammonium or the alkali metals. And the alkali metals will typically make things dissolve simply because they're so reactive. Sulfide, for example, here is normally insoluble, except when it's with ammonium, the alkali metals, calcium, strontium, and barium. So we're going to use this table to determine which is the solid. Okay, remember the precipitate is a solid. We're going to indicate it with the state of matter S. Okay, everything that dissolves in water is going to be AQ, meaning aqueous. Okay, aqueous means that it was dissolved in water, so it is soluble. Okay. So from there, we're going to determine what made our precipitate. So this example is on the bottom of page 8. We're going to start by translating the words into the chemical formulas, balancing the equation, and then going ahead with the net ionic process. Okay, so here I have silver acetate. So silver is a +1 charge. Acetate is C2H3O2 -1. So these charges are going to cancel, and the formula for silver acetate will be AgC2H3O2 plus strontium chloride. Okay, strontium is a +2, chlorine is a -1. So the formula is SrCl2. Okay, now this is a double replacement reaction. So the cation from one compound will combine with the anion from the other. So the silver and the chlorine will come together, and then the strontium and the acetate will come together. And remember, when you predict your products for a double replacement reaction, they have to be chemically correct. So I can't just copy everything over. I have to have the proper formula. So when silver and chlorine come together, silver is a +1, chlorine's a -1. So your formula will be AgCl. Okay? And then when strontium and acetate come together, well, remember, strontium's a +2, acetate is a -1. So these will crisscross and drop, and you're going to get Sr parentheses C2H3O2 2. Okay, so those are my products. Okay. So now we have the task of figuring out which of our products was the precipitate. Which of the products did not dissolve? Okay, so chlorine is usually soluble, except when it's with silver, lead, or mercury. So because of that, it becomes insoluble. Because it's insoluble, that's going to be our precipitate. Okay, so this guy is the precipitate. He is not going to dissolve in water. So we're going to keep it together when we do our net ionic equation. Okay, acetate is always, this is acetate here. Acetate is always soluble. So I know that this was aqueous in solution. Okay, so I'm going to go ahead and put my states of matter. This is aqueous. This is aqueous. And this guy was our solid. Silver chloride is our solid. So we're going to make sure it's balanced. It looks like I need 2 chlorines on the right. So I'm going to put 2 chlorines on the right. And it looks like I'll need 2 acetates on the left. So we're going to do that. So I'm going to go ahead and put in my coefficients. Okay, so I just cleaned up everything. I balanced. We needed 2 chlorines on the product side, so I put a coefficient of a 2, and that went to the silver and the chlorine. So I went ahead and put a 2 on the left side with the silver acetate. So now I have 2 silvers and 2 acetates, and I also have 2 acetates on the product side. So it is balanced right now. Okay, so this is pretty much the hardest part, is you identifying what is the precipitate using your solubility table, and then also making sure it's balanced. So I am now ready to go ahead and do the ionic equation. And the ionic equation is simply you separating everything into its ions except for the precipitate. So I'm going to go ahead and do that. Okay. So I have 2 silver acetates. So this means I have to have 2 silver ions and 2 acetate ions. So I'm going to go ahead and write that. So 2 silvers. Silver has a charge of +1. Plus 2 acetates. 2 C2H3O2 -1. This is the charge of acetate. Okay, so all I've done is I separated them into ions. Plus strontium and chloride. So strontium, there's 1 of them. So strontium's a +2 charge. And notice I have 2 chlorines, so I have to put a coefficient of 2. And then my chlorine ion is a -1 charge. Yields. Remember, you got to keep your precipitate together, so I'm not going to mess with that. I'm just going to leave it together. And then I'm going to separate everything else. So strontium is a +2. And then I have 2 acetates, guys. So I have to put 2 in the front. And then my acetate is -1 charge. So if you have a subscript that tells you how many you have. You just have to make it a coefficient because you need to show the ion. Okay, so looking at this now, I want to see what are my spectators. So what appeared on both sides of the equation? And that is acetate and strontium. So these are my spectator ions. Okay, now since they're spectators, they didn't react, they didn't participate. So everything else is now the net ionic, and those are the ions that came together to make the solid. So I had 2 silvers plus 2 chlorine ions come together to make 2 silver chlorides, which is my precipitate. So this here is your net ionic equation. Okay? So looking at page 10 on number 2, they ask, will a precipitate form if copper 2 chloride and ammonium sulfide are combined? So when those 2 compounds come together, they form copper sulfide and ammonium chloride. So looking at my solubility table, the copper sulfide will form a precipitate because sulfides are generally insoluble, whereas chlorides are usually soluble. So this is my solid, and this is aqueous. Oops. And this is aqueous. Oh my God. Okay, so now we're going to make sure it's balanced. So I need a 2 here. Yeah, we got that already. And everything else will be 1. Okay, now we're going to split them up into their ions. So for the overall ionic, copper is a +2. 2 chlorines is, I'm going to put a coefficient of 2, and then the chlorine ion is -1. Ammonium is, there's 2 ammonium, so I'm going to put a 2 in front for the coefficient, and then ammonium is NH4 +1 charge, plus the sulfide. Sulfide is a -2 charge, it's group 6. This is my precipitate, copper sulfide, so I'm going to keep it together. And ammonium, there's 2. And there's also 2 chlorines because the coefficient is 2. Okay, so this is my overall ionic right here. Now the net ionic is what came together to make the precipitate. So I look at the spectators and see who did not participate in the reaction. So it looks like it's ammonium because it appears on both sides, and the chlorine. So those are my spectators. And therefore my net ionic is what came together to make copper sulfide. So that's copper +2 and sulfur -2 made copper sulfide, which is a solid. And my spectator ions will be chlorine and ammonium. And that's how you do a net ionic equation. So go ahead and try out number 3 and 4 on page 10, and also work on page 9 for me. Page 9 is simply you predicting the products of a double replacement reaction. so it's a little bit easier. Okay, thank you so much and have a great day.